Okay, so welcome back to another video. Here's a cool trigonometric integral we want to calculate. So we have the integral from 0 to pi over 4 of sine of x plus cosine of x plus tangent of x, all divided by 1 plus sine of x multiplied by 1 plus cosine of x multiplied by 1 plus tangent x, then dx. So something like this is a little interesting because in order to actually perform such evaluation, we're going to have to do a little bit of a substitution, but not like in terms of a u substitution. We're actually going to be using it in terms of, well, we technically are, but we're actually using it in a way we're actually using the tangent half angle substitutions. So what that will do is actually reduce everything in the trigonometric form in terms of just a single variable by itself without none of the trigonometry involved. So if we can actually utilize that, then it actually just comes down to a lot of like algebra and manipulation, all that stuff. And I won't go into the details about it, but you will need to perform a nice little partial fraction decomposition later on, which of course don't need to really go into the details about that. I'm just going to leave that part as an exercise to you once we get to that step. And then afterwards, the integral itself becomes a little bit more simpler to, evaluate on its own, and then just plug and bounce from there. And that's it. Interesting thing with that, with the tangent half angle substitution, plugging that stuff together. So it'll be a nice change of pace with this. So I want to make sure to jump right in. So we'll let y equals the tangent of x divided by 2. So that means, what am I actually solve this for x by itself? So if I do that, then that means I have that x is then just equal to 2 times the inverse tangent of y. And so that means if I differentiate both sides, so that means dx is then just going to equal 2 divided by 1 plus y squared and then dy. Okay, and so actually by utilizing with the tangent half angle area, there's also the sine and cosine. If we actually find its equivalent of using the half angle substitutions, so we can actually get those to be a variable on itself. So basically it's just utilizing the formulas for after performing such substitution. So when you do that, well, first off, calculate our bounds. If I plug in 0, of course, that's just going to be 0. If I plug in pi over 4, that's going to lead us with the square root of 2, subtract 1. And so we do the substitution. Sine of x specifically has a nice formula to say that that's the same thing as 2y divided by 1 plus y squared from utilizing the whole tangent half angle formula. Then cosine of square, same thing, but this time this is going to be 1 subtract y squared divided by 1 plus y squared. And then for tangent x, that will be simply just 2y and then divided by 1 minus y squared. Okay, and then afterwards, we do the same thing over here, do that same substitution. So I have 1 plus 2y divided by 1 plus y squared multiplied with 1 plus 1 minus y squared divided by 1 plus y squared, then multiply with 1, or actually that's supposed to, yeah, no, I got it. 1 plus, and then 2y, this is where I just got it mixed up. So 1 plus 2y, then divided by 1 minus y squared. And then just substitute the dx differential. So that means it's going to be times 2 divided by 1 plus y squared, and then dy. Okay, so that just seems like a lot going on. So this part I'm just going to leave as an exercise for you to actually do the whole, get everything into a nice simplification. So a lot of that can be left up to you for your for verification. But after you perform all that, you're going to get the following. So it's going to be 0 to square root of 2 minus 1. Our numerator specifically is going to be 1 plus 4y, then subtract 2y squared, and then add this with y to the power 4. Our denominator is going to be 1 plus 2y minus y squared, then multiply with 1 plus y quantity squared, and then dy. Okay, so that's what we have so far. And yes, I know it still looks like a lot to do, which of course, I'll leave this to the verification for you guys to check out for yourself, leave that as an exercise. The next step here, we're gonna actually have to apply the partial fraction decomposition. So I'll leave it up to you to actually try this out yourself. So when you get okay, I'll actually put this here. So we're gonna apply the partial fraction decomposition. So that means I just abbreviate it as PFD. So then now applying yet again afterwards, so the square root of 2 minus 1. So what we'll get now is, after applying such step, -1, add this with 2 minus 2y, then divided by 1 plus 2y minus y squared. Add this with 2 divided by 1 plus y, and then add this with 2 divided by 1 plus y quantity square, and then dy. So as you can see here, all this is a lot simpler to actually find the definite integral, or finding its antiderivative. So by doing so, we have -y and then minus the natural log of 1 plus 2y minus y squared. Add this with 2 times the natural log of 1 plus y, and then minus 2 divided by 1 plus y. Then we evaluate our bounds from 0 to the square root of 2, subtract 1. Okay, so why don't we actually do that? So first, let's actually plug in the square root of 2 minus 1 into the formula. So then I have square root of 2 minus 1 over here, minus the natural log of 1 plus 2 times the square root of 2 minus 1. Then minus square root of 2 minus 1 quantity square. Add this with 2 times natural log of 1. 1 add this with the square root of 2 minus 1. And then subtract 2 divided by 1 plus square root of 2 minus 1. Okay, so that's that. And then now we just plug in for 0, so subtract. So plug in 0, so that means I have a -0 minus the natural log of 1 plus, so that's 0, and then -0 squared, so -0. Add this with 2 times the natural log of 1 plus 0, and then minus 2 times 1 plus 0. Yep, just to close that off. So as you can see, everything's 0. So ln of 1, 0, of course. This is just going to be 0, and then over here, this is going to be a -2 over here. So afterwards, that will be a +2 if you'd apply the minus back to over here. So after doing all this, when you do the combination and do the expansion of all this out, we're going to get the final answer. Specifically, is going to be 3 subtract 2 times the square root of 2, and then minus the natural log of 2 times the square root of 2, and then subtract 2. So with that, that will be our final answer to this trigonometric integral, which of course everything we just did for the that tangent half angle substitution just reduces down to just one variable instead of none of the none of the trigonometry involved. So with that, it just leaves us with just the following answer over here, just like that. Simply just the natural log frenzy. Well, not really natural log. There's only one natural log, and then everything else is the 3, then with the square root of 2, just like that. After all that, so yeah, that's pretty cool if you ask me.